Hi. Organic chemistry again. We are going to do few more PYQs from MCQ area from the chapter Haloalkanes and Haloarenes, which are asked in 2022. We are going to see what these questions are. Hi, I'm Prasanna. Welcome to my platform, Chemsmart. The first question is, which of the following has the highest boiling point? Ethyl fluoride, ethyl chloride, ethyl bromide, ethyl iodide. You can note one thing, in all of them, the alkyl group is same, right? Ethyl group is there in all of them, right? Only the halogen part is different. You also know when we go from top to bottom in the halogen family, the size increases when you go down the group, right? Fluorine to chlorine to bromine to iodine, the size increases. When the size increases, atomic mass also increases. That means it will result in the increase in molar mass when we go from ethyl fluoride to iodide. Molar mass increases. When molar mass increases, you have studied the strength of intermolecular van der Waals forces also will increase. What will happen then? We have to supply more heat energy to break these stronger van der Waals forces. That means boiling point will increase. So which one will have the highest boiling point? The one with highest molar mass among them, and that is ethyl iodide. Clear? So the answer here is ethyl iodide. Next question. It is, consider the following reaction. CS3CH double bond CS2, that is propene, plus HBr. First you are treating it with HBr, then with aqueous KOH. What will happen when you make this react with HBr? You know, this is an unsymmetrical alkene. And HBr is also unsymmetrical. It is unsymmetrical addendum. So what will be happening here? You can see this is H plus Br minus, right? Here, these are the two carbons holding the double bond. This carbon has only one hydrogen. This carbon has two hydrogens. What is Markovnikov rule? Positive part of the addendum will get added to the carbon holding greater number of hydrogen atoms, and negative part of the addendum will get added to the carbon with lesser number of hydrogen atoms. So what will be the product formed after addition of HBr? CS3, CH, Br, CH3. That means you will be getting 2 bromopropane when you add HBr into propane as per Markovnikov rule. Now, this compound you are treating with aqueous KOH. You know, when alkyl halides react with aqueous KOH, nucleophilic substitution will happen, right? So what will happen? This Br will get replaced by OH. With aqueous NaOH or aqueous KOH, nucleophilic substitution will happen. So what will happen? What is the product now? CS3, CH, OH, CS3. That means CS3, CH, OH, CS3. This is the correct answer. You will be getting propan-2-ol or isopropyl alcohol, common name. Clear? So this is how you have to apply. Now coming to the next question. Which of the following halides contains sp2 carbon connected to X? That is sp2 carbon to X bond. We have done the classification of halides where allylic halide is sp3 carbon connected to X. Alkyl halide is also sp3 connected to X. Benzylic halide is also sp3 connected to S. But vinyl halide is sp2 carbon connected to X. Allylic halide, if you take, say, it is CH3, CH, double bond, CH, CH2X. I'm just taking an example. If you look at this halogen is connected to this carbon, which is sp3, and that is in turn connected to sp2 carbon. So, such halides are called allylic halide. So here halogen is connected to sp3 carbon, not sp2. Alkyl halide, you know, it's already sp3 carbon connected, normal alkyl halide. Benzylic halide, what is benzylic halide? Benzylic halide is like this. Okay, so here the X is connected to this carbon, which is all single bonded. So it is sp3, which is connected to this carbon, which is sp2. So in benzylic halide also, the halogen is connected to sp3 carbon. But when you come to vinylic halide, what is vinylic halide? The simplest vinylic halide, let me take this. Here the halogen is connected to this carbon. But this carbon is a part of the double bond. So it is sp2. So we can see that in vinylic halides, the halogen is connected to sp2 carbon. So here the answer is vinyl halide, where halogen is connected to sp2 carbon. Clear? Great. Now the next one. Enantiomers differ only in one of the previous sessions, we have done enantiomers properties related question in 2023. So the same thing is asked in 2022, you can see, but in a different format. Enantiomers differ only in. You have studied enantiomers differ only in their sign of optical rotation. If one is dextrorotatory, the other one will be levorotatory. All other properties will be same. So boiling point same, melting point same, solubility same, but rotation of plane polarized light will be different. So the answer for this question will be rotation of plane polarized light. That is the only property in which the enantiomers differ. Clear? Okay. Now the next question. It is also from the textbook. In the reaction, we have cyclohexyl bromide, bromocyclohexane, treated with magnesium in dry ether. You know when alkyl halide or aryl halide or cycloalkyl halide, when they react with magnesium in dry ether, you will get Grignard reagent, right? So what will this X be? This X will be cyclohexyl magnesium bromide. Cyclohexyl magnesium, just insert Mg in between these two. So cyclohexyl magnesium bromide. You got the Grignard reagent, right? Once you got the Grignard reagent, make it undergo hydrolysis, reaction with water. There you have studied this bond will get broken. You will give H here and OH here. Out of water, split water into H plus and OH minus. You know Mg is positive in the alkyl magnesium halide, Grignard reagent. So OH minus will go with Mg plus, and this part is negative actually, this carbon. So H plus will come there, making it cyclohexane. So the answer will be option C, cyclohexane. Clear? Okay, this is a textbook question. Practice. Then the next one is, which of the isomer of pentane will give 3 isomeric monochlorides on photochemical chlorination? You know, pentane has 3 isomers. What are they? Normal pentane, isopentane, neopentane, right? And here this is neopentane, this is normal pentane, this is isopentane. We are going to see which one will give 3 isomeric monochlorides. Let us examine these isomers. If you look at neopentane, all these methyl groups are identical with respect to the central carbon. So if I take this as A, all these will be taken as A. So whether you take one hydrogen out of any of these methyl groups and substitute it by halogen, you will be getting only one type of product. That is, this will create only one single monochloride. But when you come to this is A. Then this is also A, identical from both the ends. This is B, this also will be B. But this will be a different one, which is C. So if you substitute here, you will get one product. If you substitute here, you will get a second product. If you substitute here, you will get a third product. So here you will get 3 isomeric monochlorides. Now come to option C. What about that? Here, these 2 methyls are identical with respect to CH. So if this is A, this also will be A. This is different B. This is different C. and this is different D. So if you substitute these hydrogens, you will be getting 4 different types of monochlorides. If chlorine comes here, it will be one type. If it comes here, it will be second type, third type, and fourth type. So we will be getting 4 isomeric monochlorides. Here the question is, which one will give 3 isomeric monochlorides? So the answer is option B. That is, normal pentane will give you 3 isomeric monochlorides. It is also a textbook question. Please practice. Okay. So that's all from this paper. And make sure to practice all these questions. And please do like, share, and subscribe to my channel. Also, make sure to watch all the videos uploaded in my channel, which will definitely help you in achieving your target score in 2024 board exam chemistry. Okay? See you inside for the next session. Till then, bye.